Alright, so we're on the next step, and we're going to charge by conduction. So charging by conduction, you'll see, will be similar to what we've seen with others. Here's the big thing about conduction. Conduction, unlike the others, is that we want to charge by contact. So things have to touch for charge to be passed on. So here's an example of charging by conduction using a negatively charged object. So you have your metal sphere, and it's negative. Now here's what's the deal is this is metal, okay, and we're going to get back to why that's important, because you have to have a conductor in this step. So now you brought this near an electroscope. An electroscope is neutral, so it has no charge, so it's neutral. Once the metal sphere touches the electroscope, electrons transfer from the metal sphere to the electroscope. So the charged object gives electrons to the electroscope. In doing so, the electroscope, what at one time was neutral, becomes negative. And so we charge the metal, we use the metal sphere to charge the electroscope negative. So we went from neutral to negative by conduction, which is by touching. Another way to charge is by positive, right? So again, you have a metal sphere here that's neutral. You have a metal pie plate that you have made positive, probably by rubbing it in some way, by charging it by friction, but you have a metal pie plate that's positive. When you get near the neutral sphere and touch it, what happens is electrons will move, okay? Since it has a positive charge, all right, we will start to see less positive charge on the metal sphere, or more positive charge on the metal sphere, because the electrons will jump from the metal sphere to the pie plate. The pie plate then will become less positive, while the neutral sphere becomes positively charged when you remove it. So you're going from neutral to positive. So going back here, charge is always conserved, all right? When the neutral object is touched with the negative object, the neutral object becomes negative, while the negative object becomes less negative or more positive. So the charges balance out, okay? So charge is always conserved. And secondly, you need a conductor to do this. Those spheres and those examples, okay? So let's go back here and look. These objects in our examples, right? Aluminum pie plate, metal. Metal sphere, metal, are definitely conductors, okay? So just keep that in mind.